Hi, I'm Emilio Franchi, Senior Product Manager for Anritsu Company, and today we're going to be talking about making PTC ACSES measurements over the air. And in our setup, we have a PTC ACSES radio connected to a comms manager software running on a laptop PC. We have antennas connected on the radio and also on our S412E LMR Master. And we're going to go and make some measurements for PTC ACSES. So the key first thing you need to do is set up your frequency. In our case, we're set up at 220.106.250 megahertz, and you set that up on our frequency menu. You can also validate that you are set up correctly by going into your measurements here, and you can change this back to the spectrum analyzer and maximize it, and verify that you are centered on the correct frequency. That's a key function of the spectrum analyzer. Other things that you need to set up are things such as your reference level, which will be determined when your preamp is turned on. Also, you can set up auto receive range to on or off. In this case, we're setting it up to off because we're basically in a stationary scenario. If you're in a moving scenario, such as a rail car that's moving through the network, you want to set that auto range to on, so it basically adjusts to the signal strengths that it's receiving. And next, we would go into the setups. We can look at things like our trigger setup. So we're set up for RF triggering in this case, and it's probably the default and what you want to do. Again, your RF trigger level, want to set it up around -60 dBm for over-the-air messaging or capture of the signals. Your beacon, RX ignore beacon, you want to turn that off. The only time you want to turn that on is if the only thing you want to measure are the wayside radios. When you turn that off, it gives you both wayside and beacons, which is what you want to do for a coverage test. And for your timeout, I recommend 6 seconds. In this case, it shows up as milliseconds. Basically, that's the whole length of the EBOC message, and that way it guarantees it's going to capture all the bits that are in that message. Then we get into our measurement screen. You hit the PTC ACSES Analyzer, and again, you have all of these information that's available to you. We already showed you the spectrum analyzer. The other key ones that you want to look at are things like the summary table, where you have your RF measurements first, the receive power of the signal you're looking at, the peak envelope power, and the frequency error. Then you get into more of the digital measurements, such as EVM, error vector magnitude, bit error rate, and phase and magnitude error, which are components of EVM. Your packet error rate, so basically you could have a bit error rate that could be small or large, but how does it affect the packets? So that's what you're looking at to differentiate between the two, and the number of packets that were used to make those measurements. We can also look at the payload table. In this case, it's in hex. So this is something a lot of the rail engineers know which numbers to look at, including the railroad ID that is within this hex message. And they can help to troubleshoot some of the any problems they may have as far as the rail cars are expecting versus what they're actually receiving on the rail. And we can also look at your message decode table. So for some of the messages, we actually can decode the message because we've gotten that information from some other railroads. And in this case, we're looking at sort of like the source ID, the source type is an office message. We're also looking at the time slot in the frame and time slot in the EBOC for this. And there are other things that we can look at. So I'm going to switch over to our Constellation. So there are 2 more. So the Constellation looks at the GMSK signal that is used for PTC ACSES. It's really basically a phase changing signal, so it looks like a ring. If it doesn't look like a ring, then something's really off, and you should see that on the EVM error message. And then the other one that we can look at is the eye diagram. So this is a key measurement also for PTC ACSES. Again, if you have a clean signal, you just see something like this, where you can see definitive eyes within the diagram. If it's very noisy, then you know you have some problems with the signal the quality that you're receiving. And that is PTC ACSES over-the-air measurements. Thank you very much.